This video is on the vocabulary that you will need to know for November Number Corner, and all of the vocabulary has to do with geometry. Alright, you should have a 2-page worksheet that looks like this. At the top it should say Coordinate Grids Vocabulary, and you will write your name and the date. Now, fill in the chart to explain each of the geometry vocabulary words. So, here we can see the word angle. Angle is a word that we can definitely draw a picture of. There are many different kinds of angles. Maybe you've seen one look like this or like this. Okay. So angles are two lines that meet in the middle in a point. Now we're going to write the definition of angle. So an angle is a figure formed by two rays or line segments that meet at a point. So pause the video, write that down. So if you do not remember, a ray is a geometric line that has a point at the end and goes on forever in the other direction. So draw that above the word ray. Okay? And then a line segment just starts and stops at 2 points. So it starts over here and it goes and it stops over here. And a point, which we should know, is just a point. Alright, you should have a 2-page worksheet in front of you that looks like this. At the top, it should say Coordinate Grids Vocabulary. You need to write your name and today's date. Alright, let's begin. Fill in the chart to explain each of the geometry vocabulary words. Let's start with the word angle. We are going to draw a picture of an angle in the box. So angles can look like this. They could look like this. Or this. Okay. Now we're going to write the definition in the next box. A figure formed by two rays or line segments that meet at a point. So if you don't remember, a ray has a point at one end and it goes on forever in the other direction. And a line segment has a point at both ends. Okay? And a point, of course, is just the dot. So go ahead, draw that on your paper. Then we will move on and I will explain how to do the example. Pause the video while you write this definition. Alright, example. Name the angle below. So, we should know that when we name an angle, the point that they meet, both rays or line segments meet at in the middle, has to be in the middle of when we name the angle. So the sign that we make when we do an angle looks like a little angle, like that. And on this angle, B has to be in the middle. So it doesn't matter which we put first, A or C. So it could be A, B, C, A, B, C, or it could be C, B, A. And write your angle. Angle C, B, A. Those are both correct. But B has to be in the middle. All right, now it's time to do right angle. So draw a picture in this box of a right angle. So a right angle always looks like an L. It always has 90 degrees right here. Okay, so it can be in any direction. It's still a right angle. Okay, sometimes the little square in the corner is not there, but it has to be 90 degrees, always. So the definition is an angle that has 90 degrees. An angle that has exactly 90 degrees. No more than 90, no less than 90. And now we will look at the first question. Which angle is a right angle? So we're looking at this picture. Where do you see a right angle in this picture? It's right here. So we either need to write S-E-N. So let's write angle S-E-N. Or another acceptable answer would be angle N-E-S. Angle N-E-S. And just be really careful that your angles stay looking like this angle. Okay? All right, obtuse angle. An obtuse angle is an angle that is more than 90 degrees. So it's an angle that is more than 90 degrees, but less than 180 degrees. But less than 180 degrees. Pause the video if you need to write that. So in this box, we are going to draw obtuse angles. So they have to be larger than this, but smaller than a straight line. 180 degrees is a straight line. So it has to be larger than a right angle, but smaller than a straight line. So here we go. I'm going to start and I'm going to make it a little bit bigger than a right angle. That's correct because it's between a right angle and a straight line. Here's another one. It's less than a straight line, but more than a right angle. Okay. Now let's go over to the example. Which angle is an obtuse angle? So look here. Which one is an obtuse angle? This one is an obtuse angle. Okay, so we need to write angle U-E-T. Angle U-E-T. And remember, E has to be in the middle because it's the point. Or we could say it the other way. Angle T-E-U. Angle T-E-U. All right, last one for this problem, acute angle. An acute angle is an angle that is less than 90 degrees. So an acute angle is smaller than 90 degrees. So they can look like this. It is smaller than 90 degrees. Even be super skinny, like this. Or almost as large as a right angle. So it has to be just a tiny bit smaller than a right angle. So if it's 89 degrees or smaller, so between 1 degree and 89 degrees. So where on our picture over here is there a right angle? I see one. right here. Okay, so that one is UES, angle UES, or we could also call it angle SEU, angle SEU. All right, moving on to our next vocabulary word. All right, right triangle. We just learned that a right angle has an L shape. So a right triangle looks like this. It is a triangle that has a right angle on it. So here's the right angle. That's a right triangle. They can look any way as long as they have a right angle. Okay, so they can be long and skinny or short and fat, doesn't matter, as long as they have a 90-degree angle. So a right triangle is a triangle that has one 90-degree angle. It is not possible for a triangle to have more than one right angle. All right, now let's move on to the example. Draw two different right triangles. So you need to draw two different right triangles. If I draw two that look like this, that will not be answering the question correctly. They have to look different. So this one's going to be a really tall and skinny right triangle. There's my right angle. This one's going to be very large, but have two legs with the same side. So there's my two different right triangles. All right, now let's do a scalene triangle. A scalene triangle is a triangle whose sides have three different lengths. So when we look at this, one side is going to be one length. This one might be 7 centimeters, and then 5 centimeters, and then maybe 8 centimeters. All of the sides have different lengths. We're only looking at the lengths of the side, because you'll notice that this triangle, it is scalene, but it is also right, because there's a right angle there. But right now we're just focused on the sides. The sides are what matters here. On right triangle, it was the angle that mattered. If you circle those words, it'll help you. Okay, so over here, you need to draw two scalene triangles. So here's one, and then this side's going to be shorter, and this side is going to be longer. There, they all have different lengths. And on that triangle, they have different lengths also. Okay, now let's do an equilateral triangle. An equilateral triangle means that all sides have the same length. All sides have the same length. The sides are what matter here. So here I'm going to draw all of them having the exact same length. Okay, that doesn't look perfect, but it's close. Okay, I could even redo it if that one wasn't good enough. So I'd say, there we go. That looks much better. There's an equilateral triangle. Now, you need to draw two different equilateral triangles over here. Now, one thing you'll notice is that all equilateral triangles look the same. I can't draw it like this because these two sides are the same, but this side is different. So that one is not an equilateral triangle. All equilateral triangles have the same side lengths. So they all end up looking like this. Okay. All right, and isosceles. Isosceles triangles have two sides that are the same length and one that is different. So, two sides, we're still talking about sides, are the same length, and one side is a different length. So, when all the sides are the same, we make these little tick marks that show all of them are the same. When they're all different, we show this side is different from this side, which is different from this side. So on our isosceles, it's going to be two sides are the same. So these two are the same. And then this one is a different. So this one's the same and this one's the same, but this one's different. All right, let's try another one. Two sides that are the same. And one that is a different length. See how I did that? These two are the same. This one's different. These two are the same. This one's different. All right, the next vocabulary word is y-axis. So let's draw a picture. We're going to have a coordinate grid. And our y-axis always goes vertically, so up and down. So our y-axis will be this one. Likewise, the next one is x-axis. You'll also draw a coordinate grid, but it will be the horizontal line. So a y-axis is the vertical axis on a coordinate grid. And the key word here is vertical. Vertical means, if you do not know, up and down. The one that goes up and down. Okay? X-axis is, on a coordinate grid, the horizontal axis on a coordinate grid. So the key word, again, on x-axis is horizontal, which means side to side. Pause the video if you need to write this down. All right, the next word is the origin. It is also on a coordinate grid, so we're going to draw another coordinate grid in this box. And the origin is right in the middle, where the x-axis and the y-axis meet. So it is the point on the coordinate grid where the x-axis and y-axis intersect. And intersect means meet, or they cross. Okay. Pause the video to write that down. Then you're going to come over here and you need to circle the y-axis in yellow, circle the x-axis brown, and circle the origin green. All right. The fourth vocabulary word on this page is ordered pair. An ordered pair is a set of numbers that shows a position on a graph. So a set of numbers, and a set means a group. So it's a group of numbers that shows a point on a graph. And we always write them the x-axis first, then the y-axis with parentheses around it. So over here, if we choose this one, if we choose point D, it would be 2 on the x-axis, 2, And then on the y-axis, -4. There's an ordered pair. Now for the example. Which ordered pair has 8 on the x-axis? And we're talking about these up here. Which ordered pair has the point 8 in the x-axis? We're going to look at the x-axis and go to 8. And we're going to go up and we see that it's point A. Which is, the x-axis is 8. So you're going to write 8, comma. And then the y-axis is 8 also. All right. Then the next question. Which coordinates, which is our next word, has a value of -2? So coordinates is the same thing as ordered pair. Coordinate. Which one has the coordinate of -2 on the y-axis? So we go to the y-axis and find -2, and we see that it's point C. So, point C, we go to the x-axis, -4, comma, and then point C, and we go to the y-axis, -2. Alright, coordinates. Coordinates are pretty much the exact same things as ordered pair, but a different word, because we're talking about an exact location. So a coordinate is a group of numbers that tell the position of a point. That's actually just one coordinate, so it's without the S. So a position means a location, if you didn't know that. Okay, write that down. We will draw our coordinate plane right here and then put a coordinate on it. Alright, draw your coordinate plane. Pause the video. Then I'm going to put a point here. And we're going to figure out what the coordinate is. So we look at the x-axis first. 1, 2, 3. Our x-axis is 3, comma, and then our y-axis is 1, 2, 2. And put a parentheses around it. The coordinate is 3, 2. Alright, the next word is translation. Do not get this confused within our next activity, the word transformation. Transformation is just any way that the shape moves. Any way that the shape moves. Put a box around that so you don't confuse it with any other part of this paper. You do need to know the word transformation, but it's not on this chart. Alright, translation though is when a shape slides to another place on the coordinate grid. So here we're going to draw a coordinate grid, and then we're going to draw a shape on it. Here's my triangle, and the triangle is going to slide to another position. So it hasn't changed shapes, it's just moved. It also is important to notice that the triangle did not rotate at all. It did not do that. Because if it rotates, then we come down here and we call that rotation. But translation just means to slide. So the important word here is slides. When a shape slides to another place on the coordinate grid. Okay. Here we are starting with this black triangle. This is the original triangle, WIN. WIN. There's the triangle. Triangle WIN translates. It doesn't actually translate up or down. It does not move up or down. So it translates, doesn't move up or down. Sometimes if it did, we would say like it moved up 1, 2 spots. But it didn't do that. So we are going to cross that out. And then we're going to say, and it moved right. It's moving this way. We can see N moved over here, I moved over here, W moved over here. It moved to the right, and now we need to count the number of units. I know this is small. Okay, it moved over 1, 2, 3, 4, 5, 6 units. So it moved over 6 units to the right. See how that works? Now we're going to look at the word vertex. On a 2D, a two-dimensional, so flat shape or object, a vertex is the point where the sides meet. So here is a shape. It is a rectangle. Where this side and this side meets is right here. That is a vertex. Okay? We also know that this side and this side meet here. That's also a vertex. So another word for vertex is corner. All right? You need to draw your vertex, draw a shape, and circle the vertexes here. So you could do a triangle, you could do a pentagon. Okay, then you need to come over here, circle all the vertexes on the rectangle below. Where are the other vertexes? All right, 2 more words left. Rotation. Rotation is when an object turns. So the definition is when an object turns. Then in our picture, we're going to draw an object. I'm going to draw a rectangle. Okay, and I'm going to make sure that this rectangle turns. Okay, so now this side is going to be on the bottom. So I don't change the shape, I just turn it. So now, this was it before, this is it now. Now it's rotated. In our example, we're going to rotate the triangle 90 degrees. So think back to last year when we used the protractors. Okay, 90 degrees was this much. So we're going to turn our triangle 90 degrees. So now my bottom is going to turn 90 degrees so that it's over here. So I'm going to make it the same shape. There's the bottom right here. I've turned it so it's over here. And then I'm going to turn and continue to make the rest of this. So now my shape has turned. Do you see that? 90 degrees. And our last word is reflection. When you look in the mirror or a pond of water, you see yourself. So when in math, when we reflect an object, I'm going to reflect my rectangle from above. Okay? Let's say my reflection is right here. That means that whatever is on top is also going to be on the bottom. Make sense? So we're going to flip, that's the key word, flip a shape over the x-axis or the y-axis. So, if I reflect this triangle over the x-axis goes side to side. So, my triangle is going to be reflected over this axis, and I'm running out of room. But if I didn't run out of room, the triangle would be completed, and we would see that it's now flipped upside down. Okay, if I flipped it over the y-axis, which goes this way, then it would just be like a stamp. I flip it over the y-axis, and now this side is right here, and I've just flipped it over like you flip a pancake. So our x-axis example is down here, and the green one, this is the y-axis. All right, that's all the math vocabulary we need to know in order to do our next few days of math. So keep this paper in a place, like a notebook, where you can refer to it when we're doing our activities for the next few days.